right, good morning, and thank you very much, Anna, for inviting me to give a talk on flax. And my title is Flaxseed Production in the USA History. I will talk about the historical production in North Dakota or USA, flax production. And it declined. Everybody knows that it declined. And I will touch on NDSU breeding effort on development of new flax varieties. I'm Mukhlesur Rahman from I'm a oilseed breeder, so my responsibility is breeding for canola and flax both at NDSU. So as you know that there is a two types of flax. One is the oilseed flax, the other one is the fiber flax. Oilseed flax in North America, like US and Canada, we grow oilseed flax, and the difference between these two types are oilseed flax is shorter. You can see the height is 1.5 to 2.5 feet, whereas the like fiber flax is taller. And oilseed flax produce more branches, and fiber flax produce fewer branches. And oilseed flax has higher ball set, and the opposite, just fiber flax has less ball set. And oilseed flax we harvest after maturity when it's ready to harvest. But for the fiber flax, we need to harvest before maturity. So that is a just opposite characteristics between these two types. And the major use, you know, that the oilseed flax has the high omega-3 fatty acid for food. So it's very good for food, like everyday morning for our breakfast. And also the oil can be used for industrial purpose. And fiber flax just only for fiber production. Barry mentioned that from Pennsylvania. Yeah, the person from Pennsylvania contacted to me too, and we are in we I had a meeting with the person in Pennsylvania and also in Wisconsin. Couple of people like industry, they are interested to get the flax straw. And I mentioned that the North Dakota flax is not the fiber flax, but they are still interested to get this kind of straw to get the fiber from there and to make a degradable composite material. So this is the talk is still going on, and I am just looking the future that the oilseed flax we have, still we can use the straw for other purposes. Hopefully the commercial companies are coming out, and North Dakota flax will get benefited from their straw for both purpose, dual purpose, for seed and for the straw also. So let us see the global flax cultivation. You can see that the blue one is the oilseed and red one is the fiber flax. Both oilseed and fiber flax, the cultivation area is declined. You can see it is a major decline from 1960 to 2020. And also the production. So you can see that both oilseed and fiber flax, the production is also declined. The You can see that the acreage decline, the rate is high, but the production decline rate is low because breeding effort has been given and we're getting more yield per acre, and that's why the production also going little high because of low acreage, that we are still losing the production. So let us see the major flax growing producing countries. So if we see the oilseed flax, you can see that Russia #1, then Kazakhstan, Canada, China, and USA produce 4.5% of all world production. So this is the average from 2014 to 2023, last 10 years average. But for the fiber flax, only one country, you can see that the France itself produce over 75% fiber flax in the world. And rest of the countries, they produce about 25%. So France is leading fiber flax producing countries in the world. So let us see the US flax cultivation area. So I got this data from Fall State. You can see now from 1961 to 2003, you can see a big decline. See, in 1961, the acreage was 2.6, over 2.6 million acre flax produced in USA. So that is a 10 years average from 61 to 70. And here is 10 years average, from 14 to 23. So average is 285,000 acre. But still, it is declining. You can see 2019, we in USA we produce 374,000 acre. Now it is 140,000 acres. So it is still declining. The production, because the acreage is declined, production is also declined. So you can see the acreage declined 9.2 times, whereas the production declined 5 times, but still it huge decline. And production did not decline at the same rate because we are doing the breeding effort to increase the yield potentiality that reduce that loss. So in 1961, 10 year from 61 to 10 years, the US produced 1.6 billion pound, whereas it went down to 310 million pound. So as I mentioned that the breeding effort, you can see 1973, it's 50 years. This is the 5 years average. It was 9.6 bushel per acre yield. Now, 5 years acreage is 19 bushel. In even very sure that in 2024, the average yield was 23 bushel per acre. So, but this is the 5 years acre average. So that's why it is 19 point. But if you compare this 5 year and this 5 year, the yield potentiality increase just double, 2 times. US flax export and import. So you can see that the export, we are always US is always very high in import and less to export. You can see that average import from 1981 to 2024. 5.275 billion bushel, whereas export was 880 billion bushel. So, like US need flax, but we are not growing enough flax in USA. Here is just 2022 data, US and Canada flax export and import. You can see that the US is always blue one is USA and red one is Canada. You can see that US import $234 million of flax and export only $13 million. Just Canada is just opposite. It exported $179 million flax product, but they import low. So US and Canada, for in respect of the flax production, like in import and export, just opposite. So flax producing production during World War II, as everybody knows that during World War II, there was a high demand for flax oil for military purpose, especially for the military equipment, ships and aircraft, so for coating agent. So that's why the demand of flax was increased a lot, but there was just worldwide supply chain disruption occurred during that time. And that's why the US government encouraged the farmers to produce more flax and gave the incentive for that production. Also, flax was identified as a rotation crop, which improved the soil health. So these are the major causes for the increase of the flax production during World War II. But why the flax acreage and production is declined? So there is possible causes. That these are the causes I have identified over reviewing different articles. So the first one is alternative profitable crops. So in growers, they can make more money from soybean, corn, canola, or wheat rather than flax, and that's why this crop acreage, corn, soybean, and canola is increasing, and reducing the flax acreage. And market demand, although flax is very high omega-3 fatty acid, but the other oilseed crop like canola and soybean is taking the market of flax. And processing facilities, we have limited processing facilities in USA, so that the farmers growing flax probably they might have difficulties to sell their product to the processing facilities. So this is my understanding. And weather change, like a drought and flood, that can negatively impact flax. So that is also one kind of limitation. And research support, as we have seen that the acreage is declined. That's why there is not much money for check-up money for available for research. So that's why the breeding effort or other research effort is low in flax research. Not a good reflex. Yeah, you know that the two states in USA, like North Dakota and Montana, they produce flax, and North Dakota produce 67%, whereas Montana produce, sorry, the acreage, sorry, it's the planting area, 67% and 33% in Montana. But the total production is not equal 77% and Montana is 23% because Barry mentioned that the seed yield potentiality in Montana is lower than in North Dakota. So now I'm going to talk on NDSU Flax breeding program, like what we are doing in for breeding and improving the yield potentiality of flax. So flax breeding research at the flax research started in 1890. So it is 134 years old program. So here the list of the researchers or breeders have been working in flax program. But here is a person like I always honor and salute this person, Harold Henry Flor. He discovered the theory gene for gene relationship in flax using the flax rust. And this gene for gene theory has been teaching all over the world in academic institution and universities. This is a basic theory developed by Dr. Flor. And I strongly believe that Dr. Flor deserved a Nobel Prize for this discovery. So here is a list of the flax varieties released by NDSU and some, excuse me. List of the flax varieties released by NDSU. So these are the yellow and brown seeded, only three yellow seeded cultivars, and most of them are brown seeded. And in Canada, you can see lots of varieties released from Canada, and those most of them are brown seeded, and only few of them are the yellow seeded varieties. So the breeding objective, like all the breeding program has the breeding objective. The common it is oil seed crop. So the common objective is the high seed yield, high oil content. These are the two. But also we look for the disease, Fusarium. This is the major disease, and flax rust, another disease. And also like since I took this program in 2017, I have been trying to increase the genetic diversity in flax by making crosses with the diverse population. So I will show it. And new methods, we have been incorporating genomic selection and high throughput phenotyping in flax breeding program. So in flax program, we have different colors of seed. You can see that bright yellow and golden yellow and light brown, dark brown. So different kind of seed color we have available in our program. And this is the schedule of the breeding program. So this is just making the crosses and developing different populations and testing in the field and also testing under the variety trial. So these are the activities in common for all breeding programs. So we usually make 200 crosses every year, and now we have about 5,000 plots every year. And yeah, testing locations. So the blue, three blue, this is the location under the NDSU Flex breeding program. So Fargo, Castleton, and Carrington. And pink one, this is the variety trial. You can see Carrington, Langdon, Minot, Williston, Dickinson, and Hettinger. So that covers the throughout the state, the north to south, east to west. So and also mid central area too. Flax breeding trials, as I mentioned. So this is one of the trial in Fargo. You can see that how the plots look like. And this is the greenhouse activities. We do lots of greenhouse activities like making the crosses and developing the populations. And disease screening. So this is the left one. This is the rust screening. You can see that there is a huge rust, the susceptible varieties, and we can find out the tolerant varieties. And wilt, fusarium wilt. So this is the plot last year in Carrington. You can see that the fusarium wilt infection and some varieties they survived and they are growing very well. So this is the way I could identify that the lines which are tolerant under the field conditions. So this is just a special occurrence happened only this year. But we have the historical nursery called the NDSU plot 30. In plot 30, we have been growing flax 130 years and we are increasing the disease pressure of fusarium wilt. So this is a very good plot for screening our material every year. So I'm just showing the two lines we are going to release next year, ND FB24 and 13. You can see here, this is the result in NDSU Flax variety trial. You can see here that variety trial in different locations from 2020 to 2024. So the average is here is the average for 24 and 13. So over the mean, it is like a 5 years average over the mean 7.3% higher yield, and 13 has 5.8% higher yield. But you cannot find any cultivated commercial varieties which overpass this yield. So these are the two lines we are going to release next year. So we are going to increase seed this year. So probably seed will be available for growers next year or early next year or probably after next year, but depends on how much seed we are producing this year. So increasing genetic diversity to get new cultivars, new lines. So we collected 380 diverse line germplasm. Those are the originated 30 in different countries. And then we did the partial genome sequences. And then after sequences, we did the classification based on the genomic data. We find out 7 different classes. You can see that it can classify the European is one group, American and European, this is another group, and then American like NDSU material in one group. Turkeys, Africans are other groups, and the fiber type they fall in another group, and Asian, the like Indonesian, Pakistan, those are the other groups. So we can differentiate those like 377 germplasm in different groups. And based on these group, these are the one of the line. You can see this line. This is the one of the germplasm accession. So we planted those 377 germplasm in the field, and then we selected different parents. You can see different groups. Parent different, like P1 means parent one. 8 different parents we selected from different groups to make the crosses to increase the genetic diversity. So then we start to developing the magic population, make the crosses between parents, and finally F1s, and then from F4 we will start to do the field evaluation. So that is the way we can increase the genetic diversity for different traits, yield, oil, and some other traits too. Genomic selection, so another method has been using in many breeding programs, especially in the commercial company. So in the genomic selection, what we need to do, so we have to develop a training population. So let's say 200 breeding lines. We need to evaluate those lines in multiple locations, multiple years. Then whenever we have the solid data, then we can do the genotyping, and then we can identify the genomic prediction models. So the models So there is just 14 different models can be identified. Once we find out the best model which can predict the yield and other trait, then we can grow the unknown breeding population. Say we have the 1,000 breeding population. So 1,000 breeding population we can plant in the greenhouse. We can take the DNA from there and then we can do the genotyping on 1,000 lines. And based on the prediction model we have developed before, we can apply this prediction model. And from this prediction model, from 1,000 lines, we can select 100 lines. So that is the way those 1,000 lines should have the higher yield and higher traits like the breeding objective we focused for this model development. So that is the way we can increase the breeding efficiency and reduce the cost of breeding. So we did genomic prediction on 10 different flax trait. We have actually published some publication from there. So these are the different models, 14 different models, and we find out the G blob, RR blob. So these are the just for the people who are working on these. So we find out the models which can predict high yield and other trait also. So I'm also highly interested for high throughput phenotyping. So in my breeding program, so this is the like drone and robots I have been using in both flax and canola for high throughput phenotyping. So in flax field, we flew drone 5 different times growth stage. You can see here 5 different stages, multiple stages we time and multiple locations too. And then we find out the data and also the drone. We have the multispectral camera which has a 10 band image, and then those images was processed at Dr. Paulo Flores labs. He got 38 vegetation indices. You can see those are the indices, the digital number. So basically, the image data he converted those to digital number, and he provided this digital number to me, and then I did a correlation between yield and other traits. And after correlation, I find out, so these are the different traits. You can see that different color means the flying time, 51 days, 66 days, 72 days, and 77 days, and 98 days after seeding. So we can see that the blue bar, you can see the blue means 66 days. Drone flight of flown at 66 days in both advanced hill trial and URN. Both trials, the blue bar means 66 days, giving me the highest correlation value. And here also the blue bar, you can see that blue, sometimes yellow means, sometimes green means 51 or 66 days. That is the breeder's value, like breeder's score. So I score in the field. Finally, we find out that is a multiple times flying on different flax yield, yeah, flax trials, and we find out the correlation, which showed the strong correlation at 66 days for the seed yield. So this is a very good information for us, so that we can just send the drone to fly over the flax field after 66 days of the planting. Then we can get the data and then we can find out that we can predict the yield. So yield prediction is very important. So like at that stage, if we can predict yield, then we don't need to harvest all. Say I have 1,000 plots, I don't need to harvest all 1,000 plots. So based on this prediction, probably I will harvest 400 plots. So that is the way we can increase the breeding efficiency. And on the other way, like if we get any like a high wind or hailstorm, and if the experiment is damaged, but still we have this data which can predict the plots which has the higher yield potentiality. So this is very good like tools for the breeding program. So I'm also using robots. We got the USDA funding, and my collaborator is Dr. Paulo Flores from NDSU and UCLA, Dr. Khalija, then Dr. Wei Wang. So they are developing different types of robots for our purpose. So here you can see the small robot for weed control, and this is a big robot. You can see the whole plot. It can run over the. These are the autonomous robot. It can run over whole plots. It can spray for the weed control, and it has the camera. It can take the photos, and then those photos. This is canola. So those photos we can use for developing the prediction model. And UCLA group, they are also using the artificial intelligence and machine learning for converting those different data for our purpose. So here is a video. Probably might like it. So yeah, that's all of my presentation, and I would like to pay my sincere thanks to Emery Flax for funding, continuous funding, although it is not much. And Barry mentioned that because the like a check of money, and we also got the funding from USD and IFA for our research, and also we got funding from Crop Improvement and Seed Association. And thank you very much for your attention, and I will be happy to answer any question if you have.